So hello students, so this is paper 2, okay, part A, industrial chem. So I know some of you have problem in drawing the graph, but it doesn't matter if you, so there are two ways I told you before, so use lineal node, then use a ruler, but if you, some of you don't have ruler, then you just enlarge the, this graph, okay, and then use a ruler and try to use a color pen to draw it. Okay, and then you copy to the your answer sheet. If I found that you can draw a graph similar to this straight line, then I still can give you 1 mark. Okay. So now let's see the question one by one. What's the activation energy? So just like the hill, the peak of the hill. If you want to cross the hill, you have to climb up the hill until the peak, right? So the minimum energy means the height required for a reaction to occur. And then for next for part 2, ask you to determine the activation energy by using the graph of a log k against 1/t. Log k 1/t, this we should be very familiar with this because we have learned one of the equation, Arrhenius equation, k equal to a times e to the power negative ea over rt, and then we take log for both sides, it will become like this. And after that we write it in a linear equation form, log k equal to negative ea over 2.3r times 1/t plus log a, which is similar to y is log k, and m actually is the negative ea over 2.3r, actually is the slope, c is the log a. Okay, and then by draw the straight line on the graph along the points, and then we can find out two coordinates. So these two coordinates I have find for you. So one is y, then we didn't find out the slope by using y2 minus y1 divided by x2 minus x1, right? So slope equal to negative 5 is y2 minus negative 3. Okay, so that's here y2 minus y1 and over the corresponding x coordinate. And then don't forget times 10 to negative 3, okay? And then after that, the answer is a negative 10,000. And then we just, this one is the slope for finding the EA. So EA equal to this expression, and then turn out equal to 191130 joule per mole, because this R is joule in unit, so that if you want to change the unit into kJ per mole, you need to divide by 1000. Okay, so it is have a range up to positive negative 10%, so around from 170 to 210. Okay, if your answer within this range, you still can get mark. Okay, so this is for part 2. I think it's so straightforward. If you so the main point, you need to memorize this equation, okay, or this equation. And then for part 3, this also familiar. Suppose electrolysis of brine by using membrane cell. Right? Membrane cell, we have two half equation because we know that brine is a concentrated sodium chloride solution. So when we do the hydrolysis, and hydrogen, okay, which is attracted by the cathode, right? Cathode attract Can, and anode will attract anion. So hydrogen ion will eventually discharge. You know, hydrogen ion is OA. This column is OA. Another because it occur reduction. Another column is RA. This negative anion will occur oxidation, so RA. Okay, then Cl minus will eventually discharge because concentration effect. So turn out these two half equation. And then what's the advantage by using this membrane cell rather than in manufacture of sodium hydroxide ion? So compared to the flowing mercury cell and one of the cell is out of series. So the advantage should be there's no sodium chloride. Okay, the sodium hydroxide obtained that contains no sodium chloride, or this setup actually do not contain the poison mercury. Okay, so that this is also the advantage of this Mending cell. Okay. Okay, then we go to 1b. Let's see the question. Let's see this. Suppose this part is related to Wade's equation. Okay, so the formula unfamiliar, and then here the table is the change in concentration against time. That means that when x, the concentration is getting decreases along the time, and then part 1 asks you calculate the rate of consumption, right, of x. X supposedly will the concentration of x will be decreased along the time. That means that the rate, let's see the rates. Okay, first 20 seconds, then we use the change of a concentration in 20 minutes. So the equation is here, right hand side, because we know that rate of consumption is getting decreased, so that it's a negative. Okay, because decrease, so there's a negative, so rate equal to negative, and then use 0.52 here, 20 seconds, minus the original concentration 0.64 divided by the time 20 minus 0 actually, so the turnout and then the rate equal to positive 0.06 mole per diem per second. And for 60 seconds still use the same methods. Okay, then still calculate, the answer is 0.006. Some of you may not realize that the rate of consumption has a negative sign. So some of you may find the answer is negative 0.006 mole per diem per second. I think it's still acceptable. Okay, if you give me this answer. Okay, for part 2, result of B1 and then deduce the order of reaction. Okay, we always have this kind of question in DSC. So by using the data of part 1, we know that when the concentration decrease but rate unchanged, that means that, okay, here that didn't change, the rate consumption didn't change when the concentration of X changed. That means that no matter how you change the concentration, the rate did not affect it. Okay, that means that rate is independent of the concentration, right? So if independent, then we say that the order of reaction is zero order. And then as you sketch the concentration with time, so we get decreasing. Okay, so we should draw a straight line. This one seems that this straight line is just in appear in one of the year past paper. Okay, you can see the concentration keep decrease, but the weight doesn't change, because what's the weight? Weight is the slope. Use concentration divided by the time, then you can find out the rate. Okay, corresponding rates. So the slope unchanged, that means that weight unchanged. So even concentration changed, but the weight unchanged. So zero order here. And then part 4, calculate the value of y. So y here, you can imagine that y supposedly will be smaller than 0.28, right? Because you can see that the concentration keep decreasing. So we know that by using part 1, the weight is unchanged. So that we just use this weight equal to negative, and then y minus 0.64 over 80 equal to 0.0006. So use the same rate because weight is unchanged for zero order reaction. Okay, so turn out y you can get 0.16. If you calculate that y is greater than 0.28, that means that you get a wrong answer. Okay, then you need to do it again and change it. And for part C, it's related to the green chemistry. Okay, let's see. For part C, This is synthetic wood, okay, for the hexandioic acid using a cyclohexanol as starting material. It's very unfamiliar, but the equation is given to you. And then first one state the reagent and condition for the first step. What is first step? First arrow is represent the first step. So you can see the functional group from the reactant is alcohol and change to alkene. That means from alcohol to alkene, suppose that dehydration occur, right? So we use concentrated sulfuric acid and then heat, that we get 2 marks. Okay, and then let's see the calculate the overall percentage of the synthetic roots is overall. So in this reaction we have 2 steps, so that all percentage yield of each of the steps we need to consider. So we just multiply each other. So 80% times 70%, and we got 56%. That's the overall percentage yield. Okay. Then for part 3, write a balanced equation for oxidation of this cyclohexane by nitric acid. That means that the overall equation is asks you to find out this one. Okay. And here the product other than the hexanediol acid means that the products we still have water and nitrogen dioxide. So all reactant and all products are given. So you just need to convert all the name into formula and then balance that, you get 2 marks. Okay, so for the reactant C6H10, you just count how many, how many carbon, 6 carbon and 10H, and then plus nitric acid, and then the products, water, and the nitrogen dioxide, and then you need to check balance. Okay, so you can check one by one. Normally we'll balance the hydrogen first, so you can just use the test and error, try and error, and then to see, or eventually we got X, 4X, this coefficient. Okay, then you get 2 marks. And then for last 4, for atom economy of the reaction in C3. So atom economy means that we need to find out the desired product, the percentage of the desired product. So desired product is this one. Okay. What's the name it? We have the name before it. Okay. So this is we call hexanediol acid. So this is a desired product. We put it on the numerator. So we sum up all their relative atomic mass, 12 times 6 plus 10 plus 16 times 4, divided by the all reactants. The reactant including the cyclohexane and also X nitric acid, because X you have to consider coefficient when you calculate the atom economy. Okay, so that part 3 and part 4, they are really correlated. If you can't balance the equation, then you cannot solve the problem. Okay, so if you cannot balance but you can use the similar method, then I think that you can get 1 method marks. Okay. Okay, now we go to analytical chemistry. So 3A normally is the species and chemical test for the species. Such as chemical test to show the personal iodine. Okay, we seldom learn the iodine, although but we're still in the syllabus. So just similar to chloride, bromide. Okay, chloride, bromide we normally use acidify silver nitrate solution, but iodine still, because they are halogen. Okay, halogen ion. So that when you add the acidify, don't forget this word, silver nitrate solution, and then a yellow precipitate formed it. For chloride, when you add the same reagent, it will form white precipitate. For bromide, a pale yellow precipitate will form it. Okay, if you add the same reagent. So this is also important for the halide. Part 2, suggest chemical test to distinguish propanol and the propanol. So when you see propanol, this is aldehyde. It's better way that you add tolerance reagent better, okay? Because this is a unique chemical test for the aldehyde. So add tolerance reagent to each of the solution, okay, or each of them. Then only propanol we add and give a silver mirror. So silver mirror is a key point. Only is also keywords inside the test tube. Then you get 2 marks already. And then such as instrumental and analytical method. We have 3 methods for the analytical instrumental. One is calorimetry. To use the calorimeter to find out the absorbance, okay, according to different concentration of the solution, color the solution. And then second one is infrared spectroscopy, very common, very important. You can find functional group based on the absorption peak. And then the mass spectrometry, also very powerful. You can identify what exactly the compound is and find out different segments, and also the molecular ion peak. Okay, so for this formaldehyde is aldehyde, okay, we have contain the CO double bond, so that we can use infrared spectroscopy to find out. We also can use calorimetry because the formaldehyde can add some reagent that make it become a colored species. So after that, then you use calorimetry, then can measure their content, okay, or the level concentration. Mass spectrometry still, okay, can test this formaldehyde, can exactly know this what this compound is, and also the concentration. Okay, then we go to part B. Part B is a calculation. Every year we have one calculation in question 3, analytical chem part B. Normally, this kind of question is have very long question, many steps, so confuse you. Let it think that it's very difficult, then you just skip it. Okay, so but if you can analyze one line by one line and understand the background, then I think that is not really difficult. Okay, let's see the question. Burning sodium in air actually can produce a mixture of solid. One is a soluble sodium oxide, another one sodium peroxide, formula given. And then the experiment would like to find out the percentage by mass of sodium peroxide in the oxide mixture. So step 1 is the sample oxide given 0.5. Actually, it contains sodium oxide and sodium peroxide, and then dissolve it in water. So these 2 equations also give it to you. And then this solution is acidified and titrated with a titrant 0.02 m potassium permanganate solution, very common titrant, and it needs 33.4, okay, of this potassium permanganate with all hydrogen peroxide formed from sodium peroxide. That means that this reaction actually is a reaction between the titration is the reaction between the permanganate ion and the hydrogen peroxide. Okay, so hydrogen peroxide and the potassium permanganate. Okay, and this is a titration. Suppose it's a redox titration because this KMnO4 is OA. Okay, it's OA. So the half equation for hydrogen peroxide is also given. So I think not really difficult. So okay, let's see question by question. What's the flame color observed when sodium is burned? Golden yellow. Okay, easy. And color change, you can see this setup. Potassium permanganate top, hydrogen peroxide at bottom. And then hydrogen peroxide is colorless. When you add drop by drop of the potassium permanganate, you add 1 drop is a purple in color, right? And then after that, the purple color disappear because it's consumed by the hydrogen peroxide. And gradually, hydrogen peroxide concentration get decreased. And then finally, hydrogen peroxide all consumed, used up okay, so that the color suddenly change from colorless to pale purple and pink. Okay, we don't suggest you write purple because only one drop of potassium permanganate added into the final solution. Okay, only one drop can get the color change suddenly, so that one drop of the potassium permanganate will not lead to the solution become purple. So normally pale purple or pink is acceptable. So be careful. And then number 3, write down the overall ionic equation involved in the titration. Okay, so titration, I just explained that there's two, one of the equation already given. Another you just need to write by yourself is a permanganate ion change to manganese 2 plus, and then you balance it. And then you need to, in order to cancel the electron, you need to multiply some number, like equation 1 times 2, equation plus equation 2 times 5, so that you can cancel the electrons. So that this one is the overall ionic equation. Okay, you get 1 mark for this. And part 2, calculate percentage by mass of sodium peroxide. So sodium peroxide is here, but we can't directly calculate its mass, so that we need to find out its products, hydrogen peroxide first, because from the titration. Okay, from the titration here. So from the step 2, information provided, the number of mole of permanganate ion can be calculated, so that here number of moles of permanganate ion equal to concentration times volume, you get the number of mole. And after that, from the equation, from this equation, okay, and we know that permanganate to hydrogen peroxide, the mole ratio is 2 to 5. Number of mole of permanganate ion is known, that just find out 0.00668, and number of mole of hydrogen peroxide you don't know, so just let it be x. Okay, and then use this boundary, this rectangular box, just so that you can find number of mole of hydrogen peroxide. X equal to cost method, and find out 0.0167. So number of mole of hydrogen peroxide, now you got it. And then after you find out hydrogen peroxide, then you can go back and find the number of mole of sodium peroxide. Okay, so by using the mole ratio 1 to 1, so that number of mole of sodium peroxide same as number of mole of hydrogen peroxide. And then with no number of mole, then you can easily find mass by multiply number of mole by the molar mass of the sodium peroxide. That gets 0.13 gram. And 0.13 gram divided by 0.5 times 100%, then final answer 26% is the percentage by mass of sodium peroxide. Okay, you get 4 marks. So not really difficult. I think every year they somehow level of difficulty some related to this. At least you can get some marks, so don't worry about it. Okay, just analyze the question. Okay, let's go to 3C. There are 3 white solids, remember, anhydrous copper 2 sulfate, anhydrous zinc sulfate, anhydrous magnesium sulfate, and then below asks you to describe these 3. How can you distinguish by using distilled water and sodium hydroxide solution? Okay, so we know that all these white solids, but bear in mind this copper 2 sulfate, it can test the water, if you still remember in Form 4. Okay, one of the methods to test the water, we can use the anhydrous copper 2 sulfate. Once it touch water, we add water, then anhydrous copper 2 sulfate change from white to blue. Do you remember this? So at the beginning you can add a few drops of distilled water to each of them. So only copper 2 sulfate changes from white to blue. So then so that you can eliminate anhydrous copper 2 sulfate already. Okay, so that remaining 2 I think it's not a must to add a field job. If you can add, if you say that, or you add deionized water to dissolve all those three solids, okay, separately, and then you find that one of the solution become blue, okay, I think it's acceptable. Okay, part two is I mean this here. You add distilled water to the remaining two solids until dissolved. After that, add sodium hydroxide solution to each of them until excess. Remember, you have to write until excess, okay? Because for this metal ion, if you can add the hydroxide ion in it, it will form precipitate. But if you can add excess amount, after that, some of the white solid, some of the precipitate will dissolve, some of the precipitate will not dissolve. So this observation we can distinguish, okay? So after that, only sodium hydroxide react with zinc sulfate to give a white precipitate, and then this precipitate will dissolve in excess sodium hydroxide. So only. Okay, that means that sodium hydroxide still can react with magnesium sulfate to form a white precipitate. But this precipitate formed by the magnesium ion cannot dissolve in excess amount of sodium hydroxide. Okay. Okay, then we go to part D. So part D is an organic compound. Normally we mix with the infrared spectrum and the mass spectrum, so very important. So I suggest you go through this video many times, including the paper one, okay, so that to make sure that you understand the concept in it. So molecular formula: X here, Y here, boiling point seems very similar, and then explain why fractional distillation is not suitable to separate. So as you can see that fractional distillation only can be used to separate one solution from this mixture with boiling point difference greater than around 15 degrees Celsius. Okay, but here the boiling point difference is really small, so that really close, so that we cannot. So for this fractional distillation of petroleum, I hope you still remember. Normally the fractions after distill off, the fraction is has a range, like the petrol, the carbon, the carbon range from carbon 1 to carbon 4, and for naphtha, that used to produce the plastic, okay, the alkene for cracking. That one, the range is from C5 to C10, something like, okay, so it's a range. And then so let's see part 2. The question is figure out the functional group in this infrared spectrum. Okay, we know that the wave number that equal to or below 1,500 we ignore it, okay, because this region we call fingerprint region. We don't consider any functional group there. Okay, and then so after that we found there's a wave number very sharp peak at wave number 1,700, and then we know that you can check the table next page. You found that the functional group should be the carbonyl bond, so that you can write the explanation. There's an absorption peak at about 1,700 cm-1. Don't forget the units corresponding to a carbonyl group. Okay, you can write exact wave number, or you can just directly copy the range from the table. Okay, next page. Okay, for next part, the next question is figure out the mass to charge ratio at 55 and 43 for the mass spectrum And so what is 55 and what's 43 right here? So remember that all the peaks in the mass spectrum, they represent the fragment ions or represent the positive ions. So when you write their structure, you have to keep positive charge for them. Okay, so let's analyze. For X, the formula is C4H6O. And if you can make a draft, like I make a draft for you already. I draw C4, and then I think that CO double bond, we have C carbonyl group already. So we draw this CO double bond. We know that maybe a aldehyde or maybe it's a ketone. But after we draw it, all single bond except the carbonyl bond. And then after we draw it, we found that there are more than 6H. It has 8H. That means that these two compound is not the exact compound we needed because it contains 8H. So that we cross out. So less 2 hydrogen less. 2 hydrogen less, that means it may contain a very important functional group, that is carbon-carbon double bond. Okay, so actually carbon-carbon bonds can also be observed in the infrared, but very difficult to observe. Okay, very difficult. Even though you cannot observe there is a CC double bond in the infrared spectrum, I think it's acceptable. But because by analyzing C4H6O and this structure, then you can find that that's 8H. Suppose this two structure is wrong. That means that H6. That means that 2 hydrogen less. You still can prove it. There is a CC double bond in X, although you cannot realize that it's a CC double bond in the infrared. Okay, and then we go to next. So you can predict that there are 3 possible structures for X if the molecular formula is C4H6O. Okay, so that one of the first molecular structure, the structural formula should be like this, and the second should be like this, and the third one may be like this. Okay, and then which one is the correct answer? Then you just need to analyze the fragment peak. Okay, on the mass spectrum. So 55 and 43. This one is 70. So by subtracting 70 to the 55, what's the left? Suppose is 15, right? So that means that the 15 of something is gone. Okay, when they are bombarded by the electron in the mass spectrometer, right? And then that's 15 is gone, so you can refer to 1, 2, 3 structure. So which one of the 15 you find any 15 fragment there? So I think that you can observe except number 1 and number 3, it contain CH3, which is 15. Structure 2 seems that we don't have any 15, right? This one is 14. So that structure 2 is wrong. So then you can figure out either 1 or either 3 lah. And then let's see further. So it contains 55. That means that it lost 15. And it also contains the 43. So what is 43 fragment ion at the mass to charge ratio at 43? So then you need to figure out what is 43. So for the structural number 1, it seems that very difficult to find out 43, because normally the bond will break next to the CO double bond, carbonyl bond, right? Because the very high electronegative O here. So the bond next to the O, that is very easy to break. So that it is contain 29. So if 29, then you can imagine that if you use 70 minus 29, then the remaining is 61, right? It's 60. No, 61. Sorry, okay, also it's a 41, right? It's 41. But we can't find any 29 and any 41 in the mass spectrum. So that, and you can also check the number 3 structure. So we found that there is a 15 here, and also CO double bond is 28. So 28 plus 15 is 43. Oh, this is exactly 43. So for this compound, we have 55, because I lost 15, that means I have 55 remaining. And then we are also 43. So that means that number 3 suppose is the structure we wanted. So number 1 is wrong. So number 3, mass to charge ratio equal to 55. So what is the structure species? What's the fragment? You need to draw it. Okay. So you just draw it, or loss 15. So this bond should be break. That was the remaining part, the left hand side. So CH2 double bond, CH and CO double bond, and positive. Don't forget the positive. So is the peak at mass to charge ratio at 55, right? So this structure correct. And then 43 is you see which bond will be break. This bond will be break. This bond will be break. So the remaining part is this one. So C you can write from right hand side. Okay. So CH3 and then CO double bond and then positive. So this is the peak at mass to charge ratio at 43. So you get it. So still another peak. So the last part is the ask you to draw a possible structure for X. So possible structure for X will be number 3. Okay, so here, just draw again. So number 3 is the whole molecular mass is a 70. Okay, the whole thing, the fragment iron, the molecular iron 70. And also when it lose 15, it become 55. When it lose 43, okay, well, it has a 43. Okay, so this is the final answer for this part. Okay, I hope you go through this video more than one time at least. Okay, so that you can more familiar with the concept. I'll just go through to you. Okay, thank you.